People don't care how much you know until they know how much you care. A tele-reminder from Teleradyo Marcelo, ang telearalan ng bawat Malulenyo.
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo, sa programang to, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo.
Pleasant afternoon, Delphilarians, especially for the grade 10 students. Okay, once again, this is teacher Richard Martinez, your broadcaster for this afternoon. Okay, so our topic for this afternoon is about the events and union and intersections of events. Okay, so our objectives at the end of the learning session, you are expected to first illustrate events and union and intersection of events. Second, define probability. Third, find the probability of simple event, union, and intersection of event. Now, let us proceed for the definition of terms. Okay, this is very important class because along the way of our discussion, you will encounter some of the terms here. Okay, let us first start with experiment. Okay, so experiment, it is an activity that can be done repeatedly with the same condition, resulting to outcomes. Okay, example of this experiment, let's say you want to roll a die, tossing a coin, or randomly choosing a ball from a box. Then outcomes. When we say outcome class, it is the results of an experiment. And then we have also the sample space, are the set of all outcomes in an experiment. And then the event is a subset of the sample space. Okay, and then let us try this given example. Okay, so given the experiment below, supply the appropriate outcomes, sample space, and events. Okay, example, our activity or experiment for this afternoon is tossing a coin. Okay, in tossing a coin, there are two possible outcomes. And then what are those? The first class is getting head. Okay, when you toss a coin, so possible it should be head. And then the other outcome is tail. Okay, when you toss a coin, okay, it should be tail. Okay, now, sample space. Okay, our sample space here is head and tail because the sample space are the set of all outcomes in an experiment. Okay, and then aside from that, the event So what would be the event for this experiment? So the possible event class is getting head and then getting tail. So therefore, there are two events here. The first event is getting a head and the second event is getting tail. Okay? Another example class. In a six-sided die experiment, okay, there are three events here. The first event, which is event A, represent the event that the number is even. Okay? And then the second event, which is represented by B, okay, represent the event that the number is a multiple of 3. And of course, for the last event, which is C, represents the event that the number is a multiple of 5. Now, using the Venn diagram class, let us try to use this Venn diagram for us to illustrate these three, okay, events. Okay, first event is event A, which is the representation of the number is even. Okay, so coming from a six-sided die, there are three, okay, numbers which we consider as even. And then what are those numbers? So the number is 2, 4, and 6. And then for event B, we have event B and circle B. As you can see, it should be represent the event that the number is a multiple of 3. And then the number multiple of 3 is 3 and of course 6. Okay, for event C, represent the event that the number is a multiple of 5. So from the six-sided die experiment, there is one number which is multiple of 5, which is 5. Okay, and of course, we have 1 here at the universal set. Next, okay, the possible outcomes are we have 1, 2, 3, 4, 5, and 6 since the die has 6 faces. Okay, so the set of all possible outcomes in an experiment is called sample space, which is denoted by big letter S. Okay, and this big letter S equals 1, 2, 3, 4, 5, 6, as what I said a while ago. Now, it should be denoted as the number of space or the number of sample space equals 6. Okay, another, as you can see in the Venn diagram, there are three events, as what I said a while back, which is event A, event B, and event C. Okay, each event consists of elements. So as you can see, we have 2, 4, 6, which is elements of A. Then we have 3 and 6, which is element of B. And the elements of the three events, including the elements outside the events, is a universal set. Now, what is a universal set? Actually, class, when we talk about the universal set, it is denoted by big letter U, and it is a set of consisting of elements in the totality of all sets. Under consideration, therefore, U equals or universal set equals 1, 2, 3, 4, 5, and 6. Okay? And then events A, B, and C are subset of a universal set. Now, let us take this given problem. Okay? So if you know the answer, class, you may use the chat box in order for you to notify your answer. Okay? So here is the questions. What are the elements in event A? So, Dorpilarian, are you ready? If you know the answer, class, once again, use the chat box for you to notify. What are the elements in event A? Okay, let us see. Okay, so the elements in set or in event A is 2, 4, and 6. Okay, next question. What are the elements that are not in event A? Okay, class, you may use the chat box. Okay, from Ezekiel 246, Lexine Josdiano 246. Now, what are the elements that are not in event A? That are not in event A? Okay, so the numbers or the elements are 1, 3, 5. Okay, 1, 3, 5. Now, when we talk about the complement of event A, which is denoted by a complement, okay? A complement is congruent to not A, or not A is congruent to a complement. Okay? Complement of an event, it is the element or elements that is not in event, but it is in the universal set. As you can see in the diagram, which is the Venn diagram, okay? So our not A here is 1, 3, 5. Okay, 1, 3, 5. Because 1, 3, 5 or the elements 1, 3, 5 is not belong to element or is not belong to event A. Therefore, we consider this as a complement. Okay? Then another one. What is the intersection of events A and B? By the way, class, when we say intersection of two events, which is, this is the symbol, okay? These are the common elements to both events, okay? To both events. So now, what is the intersection of events A and B? Again, use the chat box, class. Okay, from Lance de la Cruz, 6, very good. From, okay, from 10-3, E. Villapuerte, Joshua. Okay, so from Ella Balanay, 6. Okay, very good. Our intersection here is 6. Okay, how about what is the union of events A and B? Okay, by the way, class, when we say union, the union of two events, which is the symbol is like U. So the set of elements that are found in event A or in event B or both A and B. Now, let us go back with the question. What is the union of events A and B? Okay. Okay, you may use the chat box, class, to show your answer. Okay, okay. So the union of A and B equals 2, 3, 4, and 6. 2, 3, 4, and 6. Okay? So let us check from the chat box. Okay, so we have Ella Balanay once again, 2, 3, 4, and 6. Very good. So from Maggie Valerio, 2, 3, 4, and 6. Very good. Okay, so most of you guys got the correct answer. Okay, let us proceed. Let us take this given example, class. There are 10 chips numbered from 1 to 10. Okay, numbered from 1 to 10 in a bag. A chip is drawn at random from the bag. So let A be the event that the number is multiple of 3 and B be the event that a number is a prime number. So all you have to do is to find the following. Okay? Is to find the following. A intersection B, B, A union B, letter C, A complement union B complement. Okay? So based on the problem, so let us identify the universal set. So since the chips numbered from 1 to 10, so our universal set here is or are 1, 2, 3, 4, 5, 6 up to 10. Okay, up to 10. Okay, then A event is equal 3, 6, 9 because we are looking for the number which is multiple of 3 from 1 to 10. Okay. For event B, we have a 2, 3, 5, 7 because the event here is a prime number. So you are assigned to look what are the prime numbers in the given 1 to 10. So the prime numbers are 2, 3, 5, 7. Okay. Now, so let us rewrite. We have the universal set is 1, 2, 3, 4 up to 10. And our event A here is 3, 6, 9. And event B equals 2, 3, 5, 7. Okay, so using the Venn diagram, okay, let us put here two circle inside the rectangle. Two circle because there are two events. Okay, so in event A and B. So in event A, let us put uh, 2 on event B because the element here is part of event B. And then let us 3. So let us put 3 on event A. And then 4. 4 is on the or placed in universal set. Then 5 is placed in event B. 6 placed in event A. 7 placed in event B. Then 8 placed in universal set. And then 9 placed in event A, and 10 is placed in universal set. Now, let us take the given problem. So, A intersection B, as you notice, we have 3. Okay? Again, when we say intersection, these are the common elements to both events. In this case, 3 is the common element with A and B. Then A union B. So when we say A union B, these are the set of elements that are found in an event A or B or both A and B. So with this, we have 2, 3, 5, 6, 7, and 9. And then for letter C, we have A complement, union B complement. So to do that, let us identify first the A complement. So A complement, we have 1, 2, 4, 5, 7, 8, 10. So 1, 2, 4, 5, 7, 8, 10. And then B complement. So we have B complement 1, 4, 6, 8, 9, 10. So 1, 4, 6, 8, 9, 10. Okay. And then let us rewrite it. If the number is double, okay, we write that as 1. Okay. Just like 1. So we write 1 and then 10. The 10 is double. So we write 1 only 10. No? And then next, for the given example, number 2. Okay, Q equals all x such that x is an even number. And then x is less than 15. Okay, for event T equals all x such that x is a multiple of 5, which is x is less than 20. Now, to illustrate, so we have q equals 2, 4, 6, 8, 10, 12, 14. Okay, all of these numbers is less than 15. Okay, so we have, and then this number also is considered as even number. Okay, and then we have t. So x, all x, such that x is a multiple of 5, which is x is less than 20. So we have 5, 10, and 15. Okay, we have 5, 10, and 15. Okay, so to answer q intersection t, as you notice, we have q intersection, so we have 10. Okay, and then q union t, so q union t equals 2, 4, 5, 6, 8, 10, 12, 14, and 15. Okay, let us proceed for the example number 3. Okay, so the Venn diagram on the right shows that the number of elements in set A and B, if the number of A union B equals 25, then the number of A intersection B equals 7, and the number of B equals 10. So find the value of X and Y. So we have event A and event B. Okay, so the number of A union B equals 25. So we have X and then 7, then as well as Y. Now, let us answer the question number 1. Find the value of X and Y. So the number of B equals 7. So 7 and Y. So equals 7 plus Y. Now, the number of B equals 10. So we need to substitute. So 10 equals, then copy 7 plus Y. And then by using of APE rule, which is addition property of equality, so we need to add negative 7 both sides. Okay, so by doing that, so 7 plus negative 7 is 0. Then 10 plus negative 7 equals 3. So therefore, the value of Y here is 3. And then for Y, so the number of A union B equals X plus 7 plus Y. Then substitute the value of this, 25. Okay, so then copy the X plus 7 plus Y. And then we need to substitute the value of Y, which is 3. So by doing that, we have 25 equals X plus 7 plus 3. And then simplify, we have 25 equals X plus 10, 7 plus 3 is 10. So therefore, we need to use again the APE rule. Okay, in APE rule class, you need to add negative 10 both sides. So 10 plus negative 10 is 0. Then 25 plus negative 10 is 15. Therefore, the value of X here is 15. Now, if you add this one, okay, so we have to have a 25. Okay, so 3 plus 15 plus 10 is 25. So if we replace it, we have X is 15, and then Y is 3. So 15 plus 7 plus 3 is 25. Okay, then let us proceed to another topic, which is the probability of an event. Okay, again, the definition. In an experiment, the probability of an event is the likelihood of that event to occur. Okay, probability is a value between and including 0 and 1. Okay, so if the probability of event represent the probability of an event E, then the P of E equals 0 if and only if E is an impossible event. Then P of E equals 1 if and only if E is a certain event. Okay, and 0 is less than or equal to the P of E, then P of E is less than or equal to 1. Okay, now there are steps here. There are steps here to find the probability. Okay, so first, you need to list the outcomes of the experiment. Second, count the number of possible outcomes of the experiment. Then third, count the number of favorable outcomes. And then fourth, use the probability formula. And then what are the formula, or what is the formula? So the formula is probability of an event equals number of favorable outcome all over total number of possible outcomes. Now, okay, so which is denoted by P of E equals the number of elements all over the number of sample space. Okay, in the given example number 1 for the probability, so let us try. So a blue and green dice are rolled. So find the probability of the following events. So there are 3 events here. The first event is event A equals green die shows 6. Then the second event, which is B, equals the sum of the two numbers is 8. And then the third event, or the last event, the sum of two numbers is less than 6. Now, let us try to answer this given example. Okay, so I have here the table which represent a green die, which is 1, 2, 3, 4, 5, and 6, and the blue die, which is represented by 1, 2, 3, 4, 5, and 6. So 6 is just because a die is or has a 6 faces. Therefore, we write 1, 2, 3, 4, 5, and 6, as well as the blue die 1, 2, 3, 4, 5, and 6. Now, the probability, or what is the probability of getting green die shows 6 all over the probability of getting the sample or the number of sample space. Okay, so by doing that, we have 6 all over 36 equals 1 over 6. Okay, 6 here because given that green die show 6. So therefore, we have 6. And then we got 36 plus by multiplying the 6 times 6 is 36. So 36 is the sample space, and the 6 is the number of possible outcomes. Okay, so to simplify this, 6 over 36, we got 1 over 6. Then the probability of getting the sum of two numbers is 8. So let us try getting the sum of the two numbers is 8. So from the table, we need to look that pair number which is or which have the sum of 8. So first 1, 6 and 2, 1, 5 and 3, 2, 4 and 4, 2, 3, 3 and 5, 4, and 2 and 6, 5. So therefore 5 over 36. Okay? So 5 over 36. Now, what is the probability of getting the sum of two numbers is less than 6? Okay? So by doing that, class, so we need to look the sum of two numbers is less than 6. So less than 6. So this one is 6. So we have 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10. So 10 over 36 or 5 over 18. Okay? So as simple as that, class, you can find the probability or the chances of getting the sum of two numbers is less than 8 and the sum of two numbers is less than 6. Okay? For example, number 2. So a pair is to be chosen at random from a group of 5 students consisting of 3 boys and 2 girls. What is the probability that the pair chosen consists of 2 boys, letter B, 1 boy and 1 girl? Take note, class, we are looking for pair. Okay? Now, to do that, by using a listing method, so we have the sample space here. The first pair is boy 1 paired to boy 2. Okay, this one is pair 1. Then pair 2, we have boy 1 paired to boy 3. And then so on and so forth. So there are how many paired? Okay, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 paired here. Okay, there are 10 paired. Now, to answer this given letter A, 2 boys. So try to look the paired of 2 boys. So we have 1, boy 1 and boy 2. 2, we have boy 1 and boy 3. And then 4, we have boy 2 and boy 3. And then, okay, so no more. So we have 3 over 10. Okay, 3 over 10. The probability of getting 2 boys equals 3 over 10. Okay? And then what is the probability of getting 1 boy and 1 girl? So getting 1 boy and 1 girl, so let us count. We have 1 boy, 1 girl. So 1, 2, okay, 3, 4, 5, 6, okay, okay, 6. There are 6. 6 over 10 or 3 over 5. Okay, the probability of getting 1 boy and 1 girl equals 3 over 5. Now, for example number 3, LA is drawing marbles out of a bag. There are 5 clear marbles and 3 green marbles. So all you have to do, class, is to find the probability that LA draws out a green marble. Okay, out a green marble. Okay? So the probability of getting 3 green marble equals 3 over 8. Now, let us try this given application. Okay? Given application. So as you can see, class, we have the standard deck of cards here. So we have 4 suits, and these suits are, we have clubs, diamonds, hearts, and spades. And then there are there are 13 ranks in a suit. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 ranks in a suit. So if you compute the cards, we have 52 cards in a standard deck of cards. Okay, now let us try this question. Okay, so in example number 4, a card is drawn from a well-shuffled pack of 52 cards. So all you have to do is to find the probability of getting 2 of spades. Okay? So if you know the answer, class, you may use once again the chat box in order for us to notify your answer, class. Okay, so let us check the chat box. Okay, so the probability of getting 2 of spades is equal 1 over 52. How about the probability of getting a jack? What is the probability of getting a jack? Okay, so 1 over 13. Okay, 1 over 13. Next, what is the probability of getting a red king? What is the probability of getting a red king? So, coming from Justin, May, Pagya, so 1 over 26. So, let us try. Okay, very good. Carlos, you got the correct answer, 1 over 26. Okay, how about getting a diamond? Getting a diamond? Okay, any answer from the chat box? Getting a diamond. So we have 1/4. Very good. Angelica Morante from Maggie Valerio. Very good. So from Melissa, also very good. Now, letter E. The probability of getting a non-face card. Balat-bat. Okay, 1/4. Hazel. Aranas Makapagal, 1/4. Okay. So, what is the probability of getting a non-face card? So, 10 over 13. Okay, so 10 over 13. So, from Angelica Morante, you are good. From Valeria, very good. Okay, from Melissa, you are good also. 10 over 13. Then, Alina Moros, 10 over 13. Okay, how about the probability of getting a black face card? The probability of getting a black face card. Okay, so what is your answer? Okay, from Hans Christian Roque. So let us try kung 1/2. Okay, so the answer here is 3 over 26 from Dominic de los Santos. Okay, very good. From Maggie Valerio, 3 over 26. Very good. From Ella Balanay, 3 over 26. From Margaret Galang, 3 over 26. How about the probability of getting a black card? Getting a black card. The probability of getting a black card. 12 over 13 from Hans Christian Roque. Okay, so the answer, Hans, is 1/2. Black card. Okay, so what is the probability of getting a non-ace card? From Maggie, 1/2. From Joy K. Fajardo, 1/2. Very good. Miranda, author, 1/2. How about letter H? Getting a non-ace card. Okay, so the answer is 12/13 from Ella. Okay, very good, Ella. You got the correct answer, 12/13. Then from Maggie Valerio, you got also the correct answer, 12/13. From Mark Dominic de los Santos, you got the correct answer, also 12/13. And the rest of Del Pilarian students, you got the correct answers. Now, okay, so another application class. So let us consider the Venn diagram below and answer the following questions. Okay, so from this, we have the Venn diagram below shows the favorite ice cream flavors between mango and vanilla of 50 kids in Barangay Bagong Bayan. Okay, now, how many kids like mango ice cream? Then how many kids like vanilla ice cream? Then how many kids like mango and vanilla ice cream? Then how many kids like mango or vanilla ice cream? So I will give you time, class, to answer these questions. Then you may answer it in 1, 2, 3, 4. 1, 2, 3, 4. And then as well as the intersection. What is the intersection here? Okay? So while doing your application, so I just want to say thank you so much for our department head, Dr. Marco Ronel Eusebio. Thank you, sir, for the PowerPoint presentation and script. Ma'am Cristel Laderas and Ma'am Penny Kaluwag. Thank you so much. And of course, sa mga kasama ko sa Mathematics Department, maraming salamat sa inyong lahat. Okay? And then, of course, pasasalamatan ko na rin po yung mga bumubuo ng Teleradio Marcelo sa pangunguna po ni Sir Macale, Sir Paulo, at saka ni Ma'am Hilda. Okay, thank you so much po sa inyo, no, na sa napakagandang proyekto. Okay, and then I just want to say thank you po sa ating butihing punong guro na walang iba kundi si Ma'am Bibo. Okay, sa pagbibigay po ng opportunity sa bawat teachers na nasasalang dito sa teleradyo. Actually, nakaka-boost po siya rin ng confidence. Okay, bawat isa po kami ay natututunan namin kung paano ang mag-perform sa ganitong larangan. Ano? Thank you so much, Ma'am Bibo, for the opportunity. And then, sa mga Delphilarians, particularly dun sa aking na-handle sa Beijing, SPFL Beijing, 10.6, section 10.6, 10.19, 10.17, 10.13. Okay, and of course, for the rest of Delphilarian students in grade 10, maraming salamat sa pag-tune in ninyo sa Teleradio Marcelo. Okay, don't forget to like and share our Teleradio Marcelo, ang telearalan ng bawat malulenyo. Okay, so I think may mga sagot na tayo dito from the chat box. So let us try. For given example number 1. So according to Mark Dominic de los Santos, number 3 is 3. Okay, how many kids like mango ice cream? Okay, we will focus this one, mango ice cream. Before you answer this class, you need to write the intersection first. So what is the intersection? Okay, so there are 50 kids in a barangay. So these kids is wanted to taste the different types of or the different flavors of ice cream. Okay, so there are 50 kids, and then out of 50 kids, there are 30 who like mango flavor. And then out of 50 kids, there are 10 kids like vanilla only. And then there are 7 kids here, class, as you can see, who don't like any of these two flavors of ice cream. Therefore, if there are 50 kids here, okay, so what is the intersection? Or how many kids would like to taste the mango and vanilla flavors? Okay, so here from the chat box, 13. Okay, very good. So our intersection here is 13. Okay, we add 30 plus 13 is 43. Plus 7 is, ano na, 3. Okay. Our answer here, class, is 3. Okay, 3. The intersection is 3. Okay, and then how many kids like mango ice cream? Okay. Okay, so for question number 1, mango ice cream. So the answer is 33. Okay, very good. For how many kids like vanilla ice cream? For vanilla ice cream, vanilla ice cream. Okay, we have 13. Okay, 13. And then how many kids like mango and vanilla ice cream? Mango and vanilla ice cream. Okay, 43. Very good. So how many kids like mango or vanilla ice cream? How many kids like mango and vanilla ice cream? Three in the intersection, and then 30. Okay, we have 10, 10, no. Okay, wait, no.
Makinig, manood na sa teleradyo. Makinig, manood na sa teleradyo. Teleradyo, teleradyo Marcelo. Sa gitna ng mababa na panahon, magkaibigan kami ba't ay diskusyon. Sama-sama tayo.
Okay. So for question number 1, we have 43. Then for question number 2, we have 23. And then for question number 3, we have 13. And then for question number 4, we have 53. Okay, 53. Okay, once again, class, pardon me. There is a typographical error. Instead of 50, this is 60. Okay, 60. Okay. So class, once again, thank you so much. And this is your teacher, Richard Martinez. I am your teacher broadcaster for this episode. Thank you and bye-bye.
Makinig, manood na sa teleradyo. Makinig, manood na sa teleradyo. Teleradyo, teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo. Makinig, manood na sa teleradyo. Makinig, manood na sa teleradyo. Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito,